noticed, we have been talking on the middleware series. The last time we heard about Kix and its interaction with COBOL, and today we have Todd Burch to talk to us about DB2 and how DB2 works with Friday, as you might have noticed, how that interacts with COBOL. So, Todd, welcome. Thank you for taking your time this morning, afternoon, actually, almost late morning for you, Todd, to spend and share your expertise with us here on COBOL Friday.
You're welcome, and thanks for having me. Hello, everybody. I'm coming to you from Chapel Hill, Texas, and thank you for joining today. I'm looking forward to this session. I hope I get questions, not because I create confusion, but because you're interested in this subject. So I've been working DB2 for most of my IT career. I started working with DB2 in 1984, prior to DB2 version 1, release 1 becoming generally available. So I have quite a bit of experience with DB2 under my belt. I will not profess to being a COBOL expert, but assembler or Rex, yes. So if you come in with some heavy COBOL questions, I have Paul to assist me. So let's get going. I'm going to talk primarily today about how you would code SQL in a COBOL program to access DB2 data. So first I'll cover a very high level, extremely high level about what DB2 is, and then I will talk about where the rubber meets the road and how to embed SQL in a COBOL program and how to prepare your COBOL program for execution. So DB2 is a relational database management system. It's been around for a long time. DB2 became GA in April or May, it was, of 1984. And it's gone through a lot of improvements over the last 30 some odd years. And it's a really interesting product. It's very complex, but it's in use in probably the Fortune 10,000 companies, if not more. And it's a very good skill to have to add to your COBOL repertoire. So DB2 data can be viewed as tables. Where in this first box up here on the top left, we might have a customer table. A customer table is made up of rows and columns. And so whenever you manipulate data, you would select from a table, and you would select columns from a table, and you might qualify which rows you want to look at. And then there'd be multiple tables. There's a customer table, an order table, and an item table here. I'm going to have a very simple table in my examples, and I call it Table 1. To access DB2 data, you use the structured query language, or SQL. There are three types of SQL. It breaks down into three different categories. There is DML, or data manipulation language, and this is the language constructs that we use to retrieve data with select, to update data, to insert new data, or to delete existing data. There's another construct of SQL called DDL, or data definition language, and this is how you would create your tables in DB2. So you might say create table, or create index, or drop table space, and it's not something that you would typically use in a transaction environment, but to set up your data and your tables, you would use DDL. And then a very small subset is the DCL, or data control language, and this is where you would use grant and revoke statements to permit or deny authorization to objects and different features and functions. Any questions so far? Okay, we'll keep going. One thing that's in DB2 that's important to know about is the DB2 Catalog. And the catalog is where the information about all the user objects and system objects are kept. And so DB2 uses the catalog. You can use the catalog to keep track of everything that's defined. So if you use DDL to create a table, a row would be inserted for you in the systables table. If you created a view, you would have a row in the sysviews table, and so on. So the DB2 catalog is a pretty important thing within DB2. Now, that was my high level of DB2. I don't really have time to go much deeper, and so now we're going to transition over into talking about COBOL and different ways to prepare a COBOL program. When you're going to write a COBOL program that has SQL in it, you're going to have to choose a method to prepare your program. The traditional way, or the way that's been available since 1984, is to use a component of DB2 called the Precompiler. And I'll have a slide on how that works in a second. And the other way, which is the way that we encourage people to do now, is to use the COBOL coprocessor. The DB2 Precompiler runs outside of DB2, and the DB2 Precompiler will parse the COBOL program and the SQL. It will replace the SQL statements with COBOL statements, and then the output of the Precompiler will be fed into the COBOL compiler. The COBOL coprocessor, however, runs inside the COBOL compiler, and it allows you to better leverage aspects of the COBOL language and do more complicated things with COBOL that you couldn't do with the Precompiler. And it allows you to take up new features of COBOL much sooner. And it's really just a better way to go. And the example that I'll have today uses the COBOL coprocessor. Here's a visual of the program preparation steps that you would use for the compiler. You would start with writing your COBOL program with embedded SQL, and I'll have an example of embedded SQL in a couple minutes. You would then send that through the DB2 Precompiler. The DB2 Precompiler is going to have two outputs. The first output is going to be the modified source. And so this is your COBOL program with your SQL, and the SQL turned into host COBOL statements. At this point, you just send this to the standard compiler. It produces the object deck. You would link edit it, and then that will produce a load module that you can execute. So everything on this left-hand side, if you're writing COBOL programs today, is something that you're familiar with. The other output of the DB2 Precompiler is a DBRM, and a DBRM stands for Database Request Module. And this is where the DB2 Precompiler has sucked out all the SQL statements that you have in your program and written them into a format, into 80-byte records that is stored in this DBRM. This DBRM is then used in another DB2 process called bind. And the first thing you would do is you would bind a package. The output of bind package goes in the DB2 catalog tables. And then you would use bind plan, another DB2 facility that would read those packages, and it would create some more information in other DB2 catalog tables called a plan. And so the things that tie together is when the load module runs, the load module says, hey, DB2, I want to run this plan. And so between the association between the load module and the plan is how things are run. So all this plan information is stored in DB2 and is used only by DB2. When this load module makes a call to DB2, this plan tells DB2 what SQL statements that need to be executed. With the coprocessor, the program prep steps are a little bit different. They're simpler. You start with a COBOL source program with embedded SQL, and then you compile that with the option that says that there's SQL in it. The output of the compiler is twofold. The first thing is object deck, which you could then link edit and have a load module. The other output is a DBRM, which is the same thing that the precompiler generates. And then that precompiler is used the DBRM is used in the same way that it was used with the DB2 precompiler, where you bind a package and then you bind a plan from that package, which produces the plan, which allows your load module, when it executes, to communicate with DB2, and DB2 knows what it is that you're trying to execute. So I've associated these different steps with a blue outline for the compile process that I'll be explaining. And then later on, we'll see this graphic. We'll see exactly the JCL and the statements that are used for this process to happen in red. Any questions?
There is one, Todd.
Okay.
I think it was earlier on when you were talking about DB2. So the question, and I'm going to read it as is for data and access control, what kind of privileges are required for granting and removing permissions?
Okay, so there's a long answer to that. It starts out with the person who installed DB2. You have this person called the sysadmin or system administrator, and so there's a sysadmin privilege that in basic terms can pretty much do anything in DB2. It can stop DB2. It can grant anything. It could revoke anything. But then as the hierarchy of data access trickles down, there are other authorities. There's not just system administrator, but there's database administrator. There's database control access. Security in DB2 is fairly complicated now. But one of the things you can remember is if you have authority to, for instance, a database administrator authority for a given database and all the objects within that database, you can create things, you can drop things. Anything that you create, you have access to as far as read and write access. If somebody else created the table, they would probably have to grant you access unless your system has been set up with rules and groups that will allow easier administration of data access. So it's a very big topic, but the thing is it's a hierarchy, and it starts out with the sysadmin, and then when DB2 is installed and configured, the system administrators and DBA or the database administrators would divvy out whatever authorities that you might need. As a developer, a COBOL developer, maybe on a test system, you would probably have a pretty high privilege because you would want to be able to do things unrestricted. And but moving over to a production environment, things would probably be a lot tighter controlled, and you might just have access to your data.
That makes sense. Thank you.
And this is Paul. If I can make one comment about that, just to let you know, for those of you that are listening and you're thinking about the OMP COBOL system, I have to treat it like production because I don't want you guys to accidentally hurt each other, because too much authority can create problems for everyone. So just to let you know what Todd was saying is so true, but I have to treat it like production. I can't treat it like development because you can harm each other. That was the only comment I wanted to add to the group.
Absolutely, Paul. That makes sense. Yeah. So Todd, there is one other question.
Okay.
Any issue with dynamic calls? And he further instantiated saying, especially where load module A and load module B access different plans.
Oh, Sudarshan, we're waiting for, he has to reconnect.
Oh, did we lose him? Yes. Okay, hang on. Let me bring Todd back in, team. Give us a second. Sorry about the minor glitch. He should be joining us any moment. Some internet issues on his end. Thank you for your patience. Okay. Okay, doke. We're still working this in the back end, trying to see if we can bring Todd back on. Give us a moment. Thank you, everyone, for your patience.
And while we're waiting for Todd to rejoin us, I know there's been a lot of discussion in the OMP COBOL system, people wanting access to DB2. And I will let you know that it is on my agenda to put more disk storage out there and some guidelines for the environment. But it's just a matter of me finding time to draft up a plan so that those of you that want to use the OMP COBOL system. Oh, I see we have Todd back.
Yep, Todd is back. Todd? Can you
Yes,
hear us?
I'm here. I'm trying to share my screen.
Okay, yes. So while you're doing that, maybe I can reread the other question for you, Todd.
Okay.
Yep. So the question was, any issues with dynamic calls, especially where load module A and load module B access different plans?
Okay, so dynamic SQL, if you're accessing different plans, it shouldn't be a problem. If those two plans are accessing the same table, there might be considerations with locking or isolation levels. So there are considerations anytime you're using SQL or dynamic SQL, but there's enough optimization in DB2 today where it's really the SQL of choice versus static. I mean, so many people are using dynamic SQL. SQL is coming in through the distributed data facility. So dynamic SQL is very popular today, and it's very much a viable option in DB2.
Great, thank you.
Okay, I'm going to try to share here again. I got hung up on the last request.
We see you, Todd.
Hello, hi. I wish you would see my screen. Okay, yeah, my sharing facility here is not working.
Oh, the little
It's
screen with the arrow won't work? Oops, I think, Todd, are you there? I think we lost him.
Yeah, we did. And so there is a couple other questions out there while we're getting Todd to rejoin.
Yeah.
There was one person, is there an easy to use free sandbox for SQL and DB2? Well, as you know, SQL is just the language of relational databases. And so specifically, if you're talking about DB2, there actually are some what's called community editions of DB2 that you can run in Linux, Unix, Windows, which means on your workstation. Now, we do have the OMP COBOL project, and as I mentioned earlier, there is a lab system, but we haven't officially made DB2 available yet on ZOS. But in terms of, are there easy to use free sandbox for SQL and DB2? There is what's called a community edition, and we call it DB2 for Linux, Unix, Windows, LUW. And that's a good way to kind of learn a little bit about relational database and SQL, because once you learn about SQL, it applies to all relational databases. DB2 just happens to be IBM's. And then I think MySQL from Oracle has been around for quite a while too. And MySQL was a community edition release for a while. And they were standalone until Oracle acquired them. So hopefully that answers that question. Is there an easy to use free sandbox for SQL and DB2?
Thank you, Paul. I was just going to slack you about that question.
Yeah. And let me see if there's anything on the
YouTube.
Yeah, I'm checking that right now.
Okay, thank you.
Nothing on YouTube at the moment.
Okay.
Oh yeah, it looks like the person that asked the question just said thank you, so hopefully that answers it.
Mm-hmm.
There was another person out there that did post something about beginner SQL tutorial. I've never looked at that myself, for grant and revoke privileges, to one of the comments about security. All relational databases, just to let you know, one of the principles of any relational database is internal security. So no matter which relational database, they have internal security. And as Todd mentioned early on, there is a category of SQL called DCL, Data Control Language. That's where the grant and revokes all live.
And we
Okay,
have,
can you guys hear me?
Yes.
Yes, we see you. We can
Okay.
hear you.
All right, I'm going to turn this camera off and go back to share mode. Apologize for that.
Is the share screen working, Todd, for you now?
No, it's spinning again.
Okay.
I noticed your camera's still on, Todd. I wonder if you turned camera off.
Yeah,
Do you want to email?
I'm clicking it.
Yeah, as one. Okay,
There we go.
it's working.
It's changed.
Well, the camera has turned off, so sorry, everybody. This is
Oh, I was
embarrassing.
able to answer a few questions, Todd, while you were. Yeah,
Oh, very good. Thank you.
The good news is the system's reacting to you just slowly.
Yes. Okay, well,
So, Todd, did you want to share your presentation perhaps by email with me, and I can see if I could share my screen and you can talk to it?
oh, that'd be wonderful. Let me do that.
Yeah. So we can. Yeah, only though, when you want to do the demo, you would still need to share your screen though, right? So, oops.
Yeah, we'll just take one step at a time.
Yeah.
There was one comment while Todd's getting that over to Sudarshana. There was a very good comment in the chat line. IBM has a Docker container for DB2 that I've used in the past, and the person put a put a URL there, and that's kind of fascinating to me. I never really realized that. Everything's getting containerized these days, so I may go check that Docker container. So thank you, David, for that comment.
Yeah, and while I'm waiting for getting the email to share the presentation for Todd, another new development in the DB2 space is there is now a VS Code extension for SQL. So that's new, and I think I saw an article about that on LinkedIn. So if any of you want to give that a try, and you're comfortable and are used to VS Code, and as you all know, for the COBOL programming course, we leverage that same tooling, VS Code, with the Zoe and Z Open Editor extensions. So I just wanted to throw that out there as well as a brand new offering, an extension on VS Code.
Yeah, that was an excellent comment, Sudarshana. And just to let you know, we see within IBM, we see a lot of people that want to modernize their applications. The mainframe doesn't need modernization. It's already there. It's very modern. But what needs to be done is application modernization. And some of these new DevOps and DevSecOps tooling, they're maturing very rapidly. And the Zoe platform is an open source framework that many vendors, including IBM, are adding things to. So the application modernization does include cultural changes for adopting the DevOps tools that are now just maturing. They're getting better and better.
All right.
Okay, can you see my screen now?
No, we don't. But I just got your deck,
Okay.
Todd, so I'm going to share my screen.
Okay, very good. Thank you.
Okay. Do you see my screen now?
Yes,
and I'm
thank
going
you.
to go to this slide, or no, we were down here. Is this the right slide?
Yeah, keep going. Yeah, so I had started talking quite a bit about the dynamic SQL versus static SQL. I'm not sure how much you heard, but it's probably best to move on. And then if there's questions I could answer later after this, I'd be happy to.
Okay. Paul, since I'm in full slideshow mode, I'm unable to see the chat. Can you also look for questions on Crowdcast, please, for me?
We'll do.
Thank you.
Okay, let's go to the next slide. Okay, so to compile a program and process the SQL, only three things that you need to do. The first thing that you need to do is you can see on that first graphic, line 10 is the prefix area is in red. You have to add the SQL parameter when you call the COBOL compiler. So POM equals SQL, and then that will tell the compiler that it will be calling DB2 during the compile process. The second thing that you need to do is you need to add a DD card pointing the COBOL compiler to the PDS where the DBRM will be kept. And so on the second graphic, line 28 is in red, and you can see the DBRM live DD card, and that just points to a member of a PDS. And then the third thing that you need to do is just add SQL to your program. And that can come in so many different ways and formats. Let's go to the next slide. So when you add SQL to your COBOL program, you have to delineate it to COBOL where your SQL starts and where your SQL ends. And that's done with a couple phrases. The first one is exec SQL, and then you would add whatever SQL statement that you had, and then you would end it with an end exec. So a simple example would be exec SQL, open a cursor, end exec. And just if you don't know what a cursor is, when you retrieve rows from DB2, you retrieve the rows from a table using a cursor. And this is just like if you held your cursor on a table in a word processor, and then you selected that row, you move your cursor down to the next row, and you select that row. So there's a concept of current row that the cursor points at, and so when you select, you use that cursor to tell DB2 which row you're interested in. Next slide. So here's an image of a COBOL program. This is a fairly small COBOL program. But what I wanted to show you in this particular slide is the data division in the working storage section. Here you can see that at the 01 and 05 levels, we have some host variables defined. And then we have a comment that says DB2 decalgens or cursors. A decalgen is short for declarations generator. And this is where you could define the layout of your DB2 table in COBOL terms. And so that would be a decalgen, is the COBOL statements that would reflect the structure of your DB2 table. We also see in exec SQL include a couple include statements, and the second one's commented out. The first one is required in every SQL, every COBOL program you have SQL in, and you include the SQL-CA. SQL-CA stands for SQL Communications Area. And this is where DB2 will report the success or failure of the SQL statement that was issued. The failure might be a syntax error. The failure might be a resource unavailable. Maybe somebody had stopped the table that you wanted to select from. And so it's very important to look at the SQL-CA after an SQL statement. And the most important field in the SQL-CA is the SQL code. And that's either a positive or a negative value that tells you the success. Then we have an exec SQL on line 50, which is a declare cursor. So we have a declare CS1 cursor, and CS1 is an arbitrary name that the programmer has chosen. And then we're declaring a cursor for a select statement. And in this case, we're going to select 3 columns: the name column, the serial column, and the phone column from table 1. And then I have commented out a where clause. And a where clause is part of SQL where you can qualify rows. And if we have time, I'll show you that how that works in a little bit. And then that's the end of the exec. I'm getting a little bit of static feedback. I hope everybody can hear me okay.
Yeah, for me, Todd, it's generally okay. I think if you talk a little bit slower, it won't be as bad, but it's okay.
Let me go on mute as well.
Okay, that seems to have fixed it. Okay, I'm ready for the next slide. Or questions, if there's any questions. Thank you, Daniel, for the feedback. Okay, all right, so this is the procedure division, and it's a very small procedure. And it doesn't do much in terms of COBOL, but it does a lot behind the scenes as far as DB2 goes. So the first statement that we have is, well, back in the working storage section, we declared the cursor, cursor1, CS1, and now in the executable code, we're going to actually open that cursor. And open makes a call to DB2. DB2 will then load what used to be your DBRM, but what is now your package and your plan. And DB2 will create all the internal structures that are going to be necessary to satisfy request for data from your table identified by that cursor. Open will return the SQL code in the SQL-CA. I'll show you what that looks like in a listing in a little bit. And so we move the SQL code to an output format, and then we display the SQL code. If there's a negative SQL code, we might want to see some tokens, and that's what the display SQL ERRM does. There's a more advanced way to do this, but for the purpose of today, I'm just showing you the basics here. And then we have a perform loop. While the SQL code is not equal to 0, perform until SQL code is not equal to 0. And the SQL statement that we're going to issue in this loop is fetch. And so fetch will make calls to DB2 to get the next row that's pointed to by the cursor, and DB2 keeps that pointer where the cursor is internally, so you don't have to remember it in your program. And so we selected the name, the serial, and the phone columns in our select statement, but we're gonna fetch those into HName, HSerial, and HPhone in the COBOL program. And so DB2 is going to do a lot of work behind the scenes to make this happen. He'll do data conversions. He'll do all kinds of things to get that data back into your program so your program can use it. If the SQL code was 0, if that fetch worked successfully, if there were rows to be returned, then we just do a simple display of the name, the serial number, and the phone number. And then once the SQL code does not equal 0 anymore, and it's most likely going to equal a plus 100, which means no more rows were available in the cursor to fetch, the loop will exit, and then as a good citizen, we will close the cursor, and then the program ends. So it's a pretty basic program. We open cursor, we fetch, 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 and then we close the cursor. We can go to the next slide, and if there's any questions, I'm happy to answer those. Okay, the link edit step is a little bit special for COBOL programs when they contain embedded SQL. And they're special because your COBOL program has to know, has to have a way to connect to DB2 at runtime. And so there are different, what DB2 calls attachment facilities that are available to use. There's a TSO attach, which is what we're using here. We're going to run our COB2 DB2 program under TSO batch. And so we're including the TSO version of the attachment on line 109 that says include syslib DSN ELI. And everything else about the link edit is standard typical stuff, other than the DD names pointing to the DB2 load libraries and the include statement for the link edit. If you were to try to link edit your program without that include, you'd have link edit failures because the COBOL program will be calling DB2 modules. Okay, next slide, please. Okay, so before I showed you that red box that was part of the program preparation process to do a bind package and a bind plan to make your program known to DB2, and these are the statements that you would use to do that. And I'll take a minute or two to go over what this is. So we have we're just running batch TSO under IKJF TO1. We're step libing to the DB2 load library and the LE load library. We're going to have to point to our DBRM PDS because the input to bind package is a DBRM. This DSN system SSTR, this DSN starts what's called the DSN subcommand processor within TSO. And so this DSN command tells TSO that any subsequent commands except the end statement you see like on line 139, every statement that's issued after the DSN system command will be a command for DB2. So TSO passes these commands over to DB2 and or over to DB2 modules, I should say, and then the bind is processed. And so the first statement we're doing is a bind package, and we're putting the built package in this collection called my collection ID. The input member is the highlighted member on line 124, and that is the name of our DBRM that was created as part of the compile process. All these other keywords, action, current degree, keep dynamic, and so on, are options for how you can define different operating behavior that you want to occur for your program. Some of the popular ones would be isolation on line 134 if you want cursor stability or repeatable read, or there's a couple other different isolations that you can specify. You want to say who is the qualifier for your tables, and in this case, you know, if you reference table 1, then this qualifier command says that the sysadmin is the owner of that table 1 table, and that's my ID, and so that's why I picked that qualifier, since I specified an unqualified table name in the select statement. Degree is for parallelism, so there's all kinds of different things and options that you can specify for bind package. Once the bind package completes, we're going to issue the bind plan, and we're calling the plan name the same as our package name, which is same as our program name, and it makes editing JCL really easy because you can start a whole new thing just by doing a global change. And so they don't have to be the same. I typically make them the same. When we bind this plan, we're going to pull in the collections that we need to make up this plan. And so we give it a PK list keyword on line 144, and we're just saying, hey, any package that has a collection ID of my collect ID, then it's going to be used as input to that bind plan. And so that's pretty much the program preparation process on the DB2 side of things for bind package and bind plan. Both of these commands create a ton of information that's placed in DB2 catalog tables. The DB2 optimizer, if you've heard of that thing, is used during all this process to figure out which access path is going to be used when that SQL statement is finally issued or is ever issued from that program. So there's a comment here. The plan is effectively a search path for packages. That's correct. Thank you, Paul. Okay, next question or next slide. Okay, so we've compiled, we have link edited, we have done the binds in DB2, and now we are ready to execute it. So we're just going to run batch TSO. In batch TSO, we're going to give it the appropriate step lives, and we run the DSN command processor, and then now we use the run command. And so we're going to say, hey, DB2 kickoff program, cob to DB2, and the plan name is also cob to DB2, and then that program will be executed. I see a question from Wendell. Does my collect ID have to be different for each package? No. You might want to write 3 COBOL SQL programs and have all 3 of those programs in one collection. And that makes binding your plan a lot easier because you can just pull in the collection, and that collection will consist of all 3 packages. The only thing that is a one-for-one relationship would be bind package, and the input to that package is just one member. You can't use 2 different PDS members in one bind package. So you can have many packages in a collection. Any other questions? Okay, this is the time that I'm going to try to share again. Do you need to stop sharing before I share?
I think so. Let me stop sharing, and let's see if that helps. Are you able to try now, Todd?
I've said, all right, it's going through the process. I'm going to share my entire screen. I'm going to say allow. Okay, so can you all see my screen?
Yay, success, we do.
Okay, all right, awesome. So what I'm going to get into now is this is the same program that we just went through, and I'm going to run this program, and then we'll look at the output, and then we'll make some changes. And so the first thing I'm going to illustrate is a bad SQL code. And so what I've done here is when this open cursor statement is executed, my table won't exist. And so DB2 will give me a bad SQL code. And so I'm going to submit this. I'm on VM, and I'm punching this over to MVS. It's running on MVS, and then the output is coming back to me in my VM reader. And that ding says it's back. And so I'm going to look at this line of output, and it says that there is a SQL code from the open as -204. And if I took the time to go into the DB2 messages manual to look up SQL code -204, it would say the table that you referenced does not exist. And the table name that we can see from this other SQL-CA field, the SQL-ERM field, is that the table name that was not found was sysadm, which is my qualifier, .table1. So I know that I need to go create that table. I'm going to now go to another system, my MVS system where this is running, and I'm going to give you a quick demo of a facility that DB2 provides called DB2I. It stands for DB2 Interactive, and it allows you to do several things. And one of the things that's very popular is this option number 1, which is spoofy, and that's called SQL Processor using file input. And so I've prepared a member in spoofy that will create my table that I need. I'm going to make a couple comments here. And so I'm going to create a table, and it's going to have 3 columns, name, serial, and phone. The name is a char 15, the serial is an integer, and the phone is also a char 15. And then I'm going to insert 3 rows into this table. And the first one who recognizes these names in chat gets an attaboy. So I'm going to submit this. And the output of that says the SQL code was 0 for the create table, the commit, and the inserts. So that works. So now we have a table. Do we have a winner yet?
No, not yet.
Okay, no, we don't have a winner.
I was going to say, is that from the IVP table that comes with DB2, like the vPhone, or?
No, it's just a table I created.
Yeah, okay. I was making it more complicated.
Okay, all right. So I ran my program before. I got a -204 because my table didn't exist. I'm going to submit my program again. And when it dings, it's back. And we'll go look at the output. And this is my output. Oops, hit the wrong key, sorry. Okay, so now you can see that I got an SQL code from the open that was 0. There were no tokens because there was no error. And now we see the 3 rows that I had created in my table. We have Hank Schrader, Jesse Pinkman, and Walter White, and their serial numbers and their phone numbers. And so we have a very simple COBOL program.
Someone on YouTube, someone said,
we have a winner.
On YouTube said, Breaking Bad character.
Absolutely, very good. My wife and I just watched this. We're a little bit late, but we did see it, and it's a pretty cool series. All right, so that is our basic. We just did a select, and but now let's say that we have a COBOL program requirement where we need only to get people's names that have a T in them, for whatever reason, in our application logic. And so we're going to go back and change our SQL statement, and we're going to comment out or uncomment this where clause. And so the where clause says where name, this is column name in DB2, like %T %, and that means if there's any letter T in the name, then we're going to only want to look at those rows. And so we're going to resubmit this now. Down just a tad here. And if we go down and look at our latest output, we can see that only Walter White had a T in his name, and so the other data was excluded. So this is nice. If you've written a COBOL program to go through a VSAM file of data, some copybook, to look for specific records, DB2 does all that for you via the SQL language. It's very powerful. I work in DB2 support within IBM, and I mean we see what people are doing every day, and SQL, the SQL language, SQL statements can be up to 2 megabytes long. I mean, it's ridiculous how complex some of these SQL statements can be, but it's a whole lot cheaper for a person or a company to use SQL and let DB2 do the grunt work than it is to have to write COBOL code to do all this filtering yourself. So DB2, if you go back to the 1960s, when people first started using computers, the big pain point was the application backlog, and that's still a pain point today. But it's products like DB2 that can help reduce the application backlog by taking application logic out of the application that you're writing and keeping it within the database management system, and letting the database management system that's highly tuned and highly optimized to do these types of things for you. So that's my demo. I wanted to show all of that. It's a fairly basic thing. As far as what I showed you today, things can get a lot more complicated, but I would encourage you to experiment with SQL in your COBOL programs. If you want to try to just learn SQL, perhaps you have access to DB2I and Spoofy, where you can just start typing some simple SQL and create some tables and do some inserts, and it's really fun to use. I mean, it literally is fun. I enjoy working with DB2. I've devoted my career to DB2 since 1984. And it's a great product, and it just blows my mind the things that it can do. Any questions?
Well, there's no questions on YouTube, and I don't see any on, at the moment, I don't see any on the Crowdcast, but I put a comment out there, and this happens a lot, Todd. Some people say, well, my compile worked just fine. Why can't I get to my DB2 resources? And I put a chat out there that the way I see it is COBOL knows nothing about those DB2 resources until you go to execute. Would you say that's true, or do you have any comments about that?
That's correct. Yeah, that's absolutely true. COBOL is just making external calls. I mean, internally, there's a call statement generated to some DB2 module. That DB2 module gets control, verifies several things, does a PC instruction, does a cross-memory call from the COBOL address space, wherever the COBOL address space is running. It might be IMS, might be CICS, might be just plain old batch, into the DB2 address space, and then things start really gearing up and happening. And so the SQLCA is the only way that COBOL is really going to know that anything's going on with DB2. I mean, that SQL code might say DB2 is not up and running. The SQL code might say, hey, plus 100, no more rows, or some column you selected was truncated because you didn't give me a host variable long enough to hold it, or whatever the case may be. COBOL doesn't know anything about DB2. doesn't have a clue what DB2 is. And so when things aren't working in DB2 as they're supposed to, then the SQL-CA is used, that input-output parameter, SQL-CA, to communicate back to the COBOL program what's going on. But as far as COBOL language itself, it doesn't have a clue what DB2 is.
We do have a question out there. Obviously, I think it's from Rod. This must be a pro, because he said, any limitations from within an IMS MPP, which is a message processing region, where I assume what they're talking about is the IMS MPP talking to DB2.
So I'm not an expert in IMS as far as any limitations. I mean, there are restrictions as far as how many DB2s you can connect to at once. There are system limitations on the number of connections from an MPP. But as far as I'd have to have a more focused question in order to really tell you anything else. I mean, there's a lot of limits in DB2. That's all I can really say. I did want to show you in this listing the SQL-CA structure that's used, that's defined. And so, I said the most important field was the SQL code, and that's defined. But these are the other fields that come in the SQL-CA. SQL state is popular. SQL state is a cross-platform code. So if you get a SQL state of 101.0.28 on DB2, then that 0.1.0.28 should be the same on Oracle or on Access or whatever. It's like a cross-industry standard for error codes. And so some people use SQL state. We primarily work with SQL code. The SQL warn fields, WARN1 through E. If there are any warnings with your SQL statement, then those will be reflected with codes in those fields that your program will need to look at. The SQL ERRD is an array of words that might have information in it that's useful for diagnostics if something's not working correctly. So there's a lot of information in this SQL-CA, and any time that you would need to, let's say that you write a COBOL program, you're getting an SQL code back from DB2. A negative SQL code indicates an error. A positive SQL code represents a warning. And the warning may be okay, or it may be something that needs to be addressed. So anytime you're working with your support staff that works DB2 with an issue with a negative SQL code, you'd want to give them the full SQL-CA contents so that the proper diagnosis can be done. That's very important in the job that I do.
A couple more questions are in there that I think are very good. One is, are SQL-DA structures just for dynamic SQL?
The answer to that is yes. The SQL-DA is used when you code dynamic SQL. Dynamic SQL has to be passed in host variables. So instead of doing a declare cursor with your SQL statement, you would do an SQL prepare, passing the address or passing a host variable with that dynamic SQL statement. And so the SQL-DA isn't a carrier of error information, but it's a carrier of information that describes the SQL statement, that describes the host variables, and it describes the result table that DB2 is going to produce when you get ready to fetch your data. So it's another communications area, SQL-DA, descriptor area.
Yeah, so we have one good question from the YouTube, but we may not have time to really get into it because it's more of a skills thing. I'll just literally read it. Can you tell how to use alter in Spoofy to add primary key in an existing table? But so I'll let you just address that. As you know, we may not have time to educate a person on how to alter a structure.
Well, the question was, do I know how to do it? And yes, I know how to do it.
Good point.
I would refer them to the SQL reference manual for alter. And so the syntax is essentially, alter, alter primary key, alter primary key. Primary keys are special. So you do I'd have to look in the book. I don't know about altering primary keys. There are some things that you can change quite easily in DB2 and other things you can't. So you have to kind of drop and recreate.
Right.
So I would have to, I'd have to get into the manual.
Yeah,
for that.
and that's the way I interpret it too. It's kind of like I would need to understand the structure itself to even get into the alter.
Yeah, a primary key is for those that don't know, it's an index construct for better access to data.
Mm-hmm. All right. So, Paul, any other questions on YouTube right now? Or was that the last one?
I think that was the last one. A couple of very interesting comments that are out there where people are sharing information. Oh, and then I will mention that one person said, I went to school to learn OOP, but when I got my latest job, I had to learn COBOL with DB2. Ends up, I kind of like it. So,
awesome.
Interesting comment.
Oh.
Yes, that made our Friday. Thank you for sharing that. And I just wanted to address Rod's question. Great question about, IMS. And I just wanted to throw it out there that our next COBOL Friday, which is going to be 2 weeks from today on August 21st, will be on IMS and its interaction with COBOL. So make sure you tune in and, listen to that session as well. I just wanted to once again take a moment and thank Todd. Todd, thank you so much and really appreciate your patience. I know there were some technical glitches, so we really appreciate you hanging in there and being with us this morning, sharing your expertise on DB2. This was very helpful and educational. So thank you, Todd. Thank you, Paul.
Thank you for having me.
Absolutely, a pleasure. And thank you, Paul, for taking a few questions and keeping our participants and audience engaged while we were trying to solve our technical issues.
Yeah. And
you are always
a
huge support for this webinar series. Thank you. And thanks everyone for joining us this morning, afternoon, evening. Have a wonderful rest of your Friday and see you in 2 weeks. Bye.
Bye.